Welcome to week 6. We are getting into the fun stuff now. We're going to talk about data visualization. And this first video is going to just introduce you to the package that a lot of folks use for data visualization in R. And then we'll practice constructing some basic plots. And then we'll pass it off to Tyler for the second part of this intro to data visualization and learn more about time series and some other types of data that you'll be working with. So for this, we're going to need to load up two packages. The first is one that you already have, the tidyverse. And then you'll also need to install ggplot 2. And I already have it installed, so I'm not going to download it right now, but go ahead, hit run on your computer. And I pulled up a little help file about just this package in general. So they title it Create Elegant Data Visualizations Using the Grammar of Graphics. And there's a lot of good information here if you want to learn more about the package, but I would say this is quite a popular choice for people wanting to visualize their data. It has a lot of built-in functionality that's intuitive and also creates plots that are nice looking, ready to go into a presentation or a paper. So I'm going to go ahead and comment this out. But after you install it, you'll want to call library on ggplot2. So go ahead, pull that up. And then we're going to be pulling in data from the CSV that we've been working with a lot in class. And I'm calling this surveys complete because we're going to load in the data and then actually remove any NA values because we do not want to worry about that when we are making visualizations for this exercise. So I'm going to add a pipe function, space down, and use the old filter function to remove any rows where there are NAs. And since I just want generally all NAs to be gone, I'm going to use the function complete cases to do this. So we'll read in the data and looks like it came in great. So generally there is some syntax for ggplot that I think is helpful to think about before jumping into coding. And so I'm going to type this out for you all, but essentially we have this function called ggplot, and within the function there are two main arguments that you need to put. So one is what your data actually is. And so I'm going to put this placeholder of data in all caps, but this is where you would actually name the data frame. So in this case, surveys complete would go in that space. The second part is this argument called mapping. And within mapping, you need to use the function AES, which stands for aesthetics. And essentially, this is where you tell R where you want it to get the data from in your data frame. And so you'll put the specific column names in these parentheses. So that's the second part. And then we've been using a lot of pipe functions recently, but in ggplot, it actually uses just the plus sign. So anytime you want to add anything to your plot, you will use a plus sign, and then you will put some sort of geometric function. And this is what will basically add the graphical representation of the data to your plot. Okay, so let's go through an example. So the first function, as I mentioned, is ggplot itself. So it's just the function name. And we need to let it know what data we want. So survey is complete. That's what we have loaded. So if I were to just run this on its own, what you'll see if you navigate over on your right bottom pane, if you hit the plots tab, just an empty white space comes up. And that essentially is saying, okay, I know there's data, but you haven't told me what data to plot or how to plot it. So I'm going to be blank. So to actually add points or data, we need to add the aesthetic argument. So we can copy what we've written in line 12, paste, and we're going to add a comma after survey is complete, write the mapping argument, and then call up the function aesthetics. And essentially what the aesthetics function is doing is it goes into your data frame and it pulls out any sort of matching column names that you specify in here. And so if you want to plot data within your data frame, it has to come from within, it has to be specified within this aesthetics argument. So let's pull weight for X, and then for Y, we'll do hindfoot length. And we'll hit run. And I apologize, ours being very slow on my computer today. So it's also continuing to be slow in this video. Okay, so I've hit run and still nothing is appearing. And this is because we are still missing this other piece that ggplot needs to know in order to actually make the plot. And that's how we want to graphically represent the data. So we need to add some sort of geom function. And there's lots of different geom functions based on the types of data that you have. So if you have two continuous variables that you want to plot, you could use geom point to basically represent a point on your plot. You could also use geom line to show a relationship between these two variables. If you have a situation where you have a categorical variable and a numerical variable, you could use something like geom boxplot, which we're going to play around with in a little bit. Or if you just have categorical variables, you can use like geom bar to show that data. So there are a few options. I would recommend the R graph gallery if you want inspiration for how to make different plots. There's a lot of good examples and code to go with the examples on there. So, okay, let's take what we have in line 15, we'll copy and paste that, and we are going to add a geom function. So to add, we have to write an actual plus sign, and similar to how we work with pipe functions, I think it looks a lot cleaner to space down every time you add something new to your plot. And so I have spaced down to line 19, and I'm going to add geom point to represent the X and Y data. So I've hit run on that, and it looks like my computer is actually not loading the plot images. Okay, yay, there we go. So now we can see, okay, weight is on the x-axis, y, hindfoot length is on the y-axis, and now these are the points in the data to represent what we've plotted here, weight and hindfoot length. Cool. We built a plot. So now once you kind of have something to work with, there's a lot of aesthetic features that you can play around with to take it to that next level. Mm, so I'm going to copy line 18 and 19 again and paste. And so say we want to add transparency to the points. We can go into geom_point and we can add this argument alpha and specify some number between 0 and 1, 0 being completely transparent, 1 being completely not transparent. So let's do 0.1 and see what that looks like. And yeah, again, my computer is delayed, so yours might come up a little quicker. But we can see now that the points are a little blurred. That's from the transparency. We can also add color to the points. So I'm gonna, again, copy the code I've already written and just change the values inside of the geom_point function. So instead of alpha, let's play around with color. So I'm gonna just choose the color blue, but there are a lot of color options out there, and there's a lot of different ways to specify it. And so I have another great cheat sheet for this that I will paste here, and you all can go and check it out for yourselves. But on here, it shows kind of the different packages related to color that you can extract, and it also has information on just the base R colors. So blue is, R just knows what blue is, so it's able to uh, call it up without having to load anything extra. So while that loads, I'm gonna start talking about the next thing. Great, it's loaded. So you can also color by group. And so there might be a case where, oops, we want to actually not just color everything blue, but we want to color by species ID. So as I mentioned before, in order to pull data out of your data frame, you have to set the value within the aesthetics function. And so I know I want to color by species ID. So I've written the aesthetics function here. And then I'm going to color, actually, I'm going to color by genius because species ID is, there's a lot of species. So we'll keep it a little simpler and just do genius here. And sometimes, you might be in a situation where you want to add multiple things to your plot. Maybe I don't just want these points. We can see here that now that mine has loaded, that there are a lot of different species colored, but they're kind of like grouped in these clusters on the plot. So that's pretty interesting. But it's a little hard to tell, what's going on between these different points in the different geniuses. So we can add some sort of line. Let's actually do geom smooth. Oops. To represent the relationship between hindfoot length and weight for each group. And so okay. Now we can see that there has been a line added to this plot. It's in blue, but you might be wondering, I thought that there was going to be a line per genius, and I don't want just like a line across the whole plot. Why did it do that? And that's because we have set the aesthetics to color by genius just within ggplot. And we have not actually said, hey, R, can you plot a line per genius as well? Instead, ggSmooth just took all the points together and created a line. So if we wanted to plot a line per genius, we'd have to, again, write aesthetics color equals genius inside of this geom function. And you might be wondering, that's kind of annoying and repetitive. Is there a better way? And this is where the universal plot settings feature of ggplot can be really handy. So I'm going to copy what I've written, and just now that mine has loaded, we can see that there are, in fact, now many different lines with a color associated, and they are related to the groups of data points behind them. So that's great. But what if we wanted to just tell R to do this once? What would we do? So I've copy and pasted what I wrote for the last plot. And what you can do is delete out what we've written in ggPoint and ggSmooth. And inside of the aesthetics function, on the very first line of code that we had, so I'm going to move this back over because it's a little clunky looking, we can add the same feature. So we want to color by genius. And essentially what I've done is set the universal plot setting as color by genius for any additional geom function I add to this plot. And you might be noticing that I'm getting this warning message about failed to fit group 1, and I believe it's because there is something about not enough, unique values to make the line. So now we can see that this plot looks exactly the same as when we had specified individual aesthetics for ggPoint and ggSmooth. Okay, so we have one more topic I want to get through, and this is creating a box plot, which is for categorical, oops, and continuous data. So let's say we want to plot surveys complete. We want to plot species ID, which we know is categorical, and weight. And we want it to, actually, yeah, that's all we want in that line of code right now. And we want to add geom boxplot to graphically represent the data. And we're just going to color it orange for Halloween. So essentially what this is showing is every single species ID, and then it's giving a summary of the spread of that data, the continuous data for weight for each species ID. So I believe the line is the median, and then the top and the bottom are quartile values, and then it shows the extent. But look up geom-boxplot specifically for the exact definition there. And so this is a handy way to look at differences among groups in your data. But say we actually didn't want, the outline to be orange in this box plot. We actually wanted the inside to be orange. We can use the argument fill to do that. We can also add, additional features of this plot. Oftentimes with box plots, you kind of miss like the density aesthetics that you get when you do a geom point, say. And so you can actually add that to this box plot. And I'm going to use specifically the function geom jitter. And geom jitter is like geom point. It plots points, but there is a slight random variation in terms of how the points go onto the plot. And that's to show that there are multiple points in one spot. So like with geom point, it will just plot the same value on top of the other. So you can't actually like get a sense of how many points are equal to say 200. There might be like 10 points right here, but we can't tell with geom point. So geom jitter basically spreads out how the points are put onto the plot. I know that there's a lot of data here, so I'm going to also add some transparency to this to hopefully not completely cover up the geom box plot. But I have a feeling it's still going to be hard to see. So once this loads, we can then determine, okay, how can we change this to make it more aesthetically pleasing? So, okay, great. Now we can kind of see what geom jitter has done. But it is very hard to see those box plots. So what you can do is actually change the order of how you construct your plot. So right now we're doing the box plot and then we're adding dots on top of it. But what if we reverse the order? So let's actually draw the points first and then add the box plot on top. And we'll see what happens. And you could also play around with making the box plot transparent as well. So, okay. Yeah, this is slightly better. There's definitely still room for improvement, but I think it gives you the idea that this is kind of the fun stuff. You know, you get to play around with what makes this visually appealing to folks and what really like captures the data, tells the story of the data well. So that's where I'll leave you now. And next up is Tyler with his stuff, and I'll see you all this week.